Hey folks, Jonathan here. Okay, a little time with the rain to be able to work in the shop. So just want to show you a couple things here. I had quite a few people ask about the taper on this shaft and how I got it the same on this one or how I got it on this one. So what I done, I don't even know what the angle is. Didn't even check, didn't matter. So what I did was I set this up in my lathe. I dial indicated it in to make sure that it was round, you know, that it was true. And then I took my compound on my lathe and put a dial indicator on it. And my compound moves 5 inches. This is 4.5. So I was good on that. So I went all the way to one end and I just slowly brought it up and back until I got zeroed in completely. Then I took this out, stuck this one in, did a measurement of the OD and on each end of it, and knowing what I needed, and just went at it and worked out really well, no problem at all. So everything's right with that. So now what we've got, I took an end mill and I actually machined a surface in here flat, because a drill bit going down against the taper is not going to do good. So once I got the flat done, then I went and drilled it for 4 holes to be able to get rid of some of that material really quick. And now we're going to go ahead and mill it out, and then I'm going to have to come up with something to put in there the right width, which shouldn't be a problem, to be able to run my broach through. And then I'll just keep adding the spacers to the broach until I get the corners of this thing squared off like I need them. So it's really not much of an issue at all. So now what I'm going to do is take my end mill and I'm just going to go in between it and just go ahead and make this a full slot, and we'll get that knocked out real quick, and we're well on our way. Now this wasn't really uniform. I don't think they was too worried about it, but the thickness on it changes majorly from one end to the other, and you know, it's got some wide spots and narrow spots and stuff where, you know, I think they just done it to do it. I think the only important part is the back and the front of the slot, because you're not using the sides of it really at all. You're just wedging the wedge in there. So anyway, let me get at her. Alright folks, here you go. Here's your full slot. I just gotta round the corner, or square the corners up, round them up, square them up. So we're gonna see if we can figure out how to get the broach to fit in there right to do that. I'll show you that. Okay folks, not a very technical way of doing it, but this is what I've got. I've got it spaced out, the round one first. I got it spaced out even so we can run the broach down through, and that's what I'm doing now, is pushing it down through, and it's tapered, so the farther it goes, the wider it gets. And you can see it's cutting. So anyway, we're just going to keep running it down through, and then we can put another little tiny spacer behind it and bring it over if we need to. But we're getting pretty close on the first pass. So we'll see how it looks when we're done. Okay folks, so we've got the other end of the crankshaft turned down and getting ready to do the sweat fit on it. And what I've done, the last one I built a fire under it and put a grate, but it's been raining for 2 days, so I decided that I'd better do it a little different. So I built me a little I don't know what you want to call it, furnace maybe, but anyway, here is my burner. This is the one I use on my smelter. I'm going to blow it in, and I'm hoping that it's going to come around in a circle and come back out right here and keep the heat in, and we'll lay that on top of it, and if nothing else, we'll get a bunch of the pine straw out from around here. We'll burn it out. But anyway, so that's what we're going to try, and see if we can get it hot enough. And I'll just be able to take that rod and should set it right down through the hole if we get it to expand good enough. All right, All right, and everybody knows I'm not one to talk a lot of safety, but that's a one-way check valve. And if you're going to do a stupid little setup like I got here, I'm using a 35,000 MIG tip, and I think I drilled it out because I decided I wanted to go hotter with more air. I don't run oxygen in this. Of course, you know, we'd melt everything down. I just run air from the compressor, but this is a one-way check valve, and you need to put that on there and use that. So if you do have an instance, something happens, it won't, the fire can't come back up through. And, you know, it's better to be safe than sorry, but anyway, we're just playing, so maybe we won't kill ourselves. You know, it's kind of funny. I don't need anybody around here to make me laugh. I make myself laugh on stupid stuff. I shoved the wire brush down in. Of course, while the fire is on, while it's hot, and knowing that once it went down, it wasn't going to come back up, not unless I shoved it all the way through. So it's stuck there and it's on fire. I'm trying to get it out. We'll see what happens. That ain't the dumbest thing I've ever done, but it's the dumbest thing I've done so far today. Smaller brush, I believe. Very close. It actually started down in. I pulled it out, but we're about out of gas, so I'm going to swap tanks out real quick and then we'll go from there. dummy. Like a big dummy, I got it stuck in there about a little less than a ½ inch in. So I had to flip the piston down and beat it out, get it a little hotter, be a little bit more patient. All right. All right, we waited long enough that time. So it's in there. Yeah, and I can't even turn it already, so hopefully I didn't get it too tight and shrinks up and bust something. But if there's anything that I'm known for, it's not enough tolerance. It's always too tight. I guess I get kind of iffy about not wanting something to be too loose and then screw it up, so hopefully it'll be okay. We're not going to throw no water, nothing like that on. Let it sit there. I'll come back in about an hour and we'll check it. And hopefully it won't be all cracked up and busted. This thing is kind of a weird setup, you know, it's hollow, so hopefully it won't have any issues. All right, folks, still cooling off. And there's what we got it pressed all the way up, or slid all the way up. Didn't do much pressing there. I don't know if I'm out too far or not. Probably not, but worst comes to worst, I can grind it off. But just want to make sure I had enough. But I think it's going to be okay. So what we're going to do is I will set this up in the forklift, and that way the bottom end is down on a piece of steel on the ground, and then we'll make it where I can heat it, and we'll hammer it down until it's peened around it like it should be into that taper right there. And as long as it's not protruding out past the piston, I think it'll be just fine. And like I said, I've got rings coming for it. I did break the other ring taking it off because I'm a klutz sometimes and that stuff happens. Getting a little bit big of a hurry too, and this is kind of a weird setup. You know, you don't see too many times that the piston don't have a bottom in it, but it's the way it's made, and it's the way we're going to go back with it. And 2 new rings. Of course, they'll line up just fine when you get them in there. I mean, they don't really need a bottom, but I think somehow the steam probably gets in there and helps force them out against the cylinder wall. Maybe that's the best I can tell. But anyway, you know, our cylinder wall is not perfect. It's a little bit rough, but that's okay. We can live with that too. We're going to see how it does. We'll learn a whole lot anyway. And you know, I have no doubt it'll run. You know, we just hopefully it won't bypass or anything too bad to where it causes any issues. We don't want it burning oil or smoking, right? Okay, so there's that part. Now we got to paint it. Don't have enough oxygen, so I got to wait and get some oxygen in town tomorrow. That's the story of my life, is not having enough oxygen. So me and my torches. Alright folks, there you go. She's all cooled down finally. No breaks, no cracks, nothing happened, so that's a good thing, which I didn't think it would anyway, but you never know. My luck's not the best in the world. And then crazy thing is you know, you can see this thing's hollow in there, and that's the reason. On the Bates engine we done a counter bore and threaded it and put a nut on it that didn't protrude out. So on this one I was afraid to counter bore it because I was afraid I'd get into something, you know, it'd be too thin in there because this thing being hollow. So that's why we're going to paint it over and sort of like the rivet effect, but like I said, it's not going to go anywhere. And we're a little, we're about, I guess we're pretty close to the edge anyway, so it's not, I don't think it's going to hurt a thing, just leaving it like it is and hammering it down, so it's not going to stick out too far. So that don't leave us a lot to do when it comes to the ERIE. We got to finish up the bearing on the rear. I bought the other big bearing, 7-inch bearing, so now we got to figure out how to adapt down to, or go from a 5 1/4 shaft to a 7-inch bearing. So I got to make a sleeve for that. Somehow, some way, we're going to do that. And then let me see. Not a lot to do. You know, this is most of the stuff. Waiting on the rings. Probably going to be a couple weeks before they get here. I've got to pour the foundation. I've got the measurements for it. And the Hamilton engine, the other cordless, I'm going to show you what's going on with it. Okay, so here is the piston, 13-inch bore, and the rod, which is 5 foot long. For the Hamilton cordless, it's an odd size, and we are going to go back with a 63 millimeter, which is the same thing as we done on the Bates cordless. The problem is with this one, these threads. These threads are 2.375 or 2 3/8 by 6. And if you start searching and looking, you come to the realization that they never really made a nut that was that size. So the nuts that's going to be made is going to have to be homemade or something that I come up with. And I about have to do it because the crosshead has got that same thread pattern, and the nut was missing on this. And we're going to have to do the same thing on this, machine it out, get the center out of it, and then I'm going to have to take the rod and stuff to my buddy Lawrence and let him do it, because I can't, my through hole is not big enough on my lathe, and that's too long for me to go between centers and to be able to do what I need to do to thread it and everything. So I guess as soon as I get it, come up with a nut, and I may cut this off and bore the center out and then drive the center out like I did on the other piston, and hopefully I can get these rings off without breaking them. I'm not good at not breaking them, but we'll see. And but that's our biggest hold up on this engine, and of course we got to do the foundation to start getting it put together also. I showed the other big bolts in the video. These are the smaller bolts for the outside of the flywheel. I needed 6 of them, so I had one, I bought 5 more. I wanted to keep one original on it, we'll clean it up. But these, like I said, were leftovers from a job or something that was already made this size, and I was looking for nuts and found them, so I just went ahead and bought them. Saved a lot of money actually by doing a lot of time. So you know, I paid about what the nuts were for these, and then got the threaded rod for free. And like I said, the threaded rod is not going to matter, and you're not going to know it when it's on there, so they'll work out just fine. Another thing also, here is the one bolt that I do have for the center of the flywheel, and I bought some bolts in there to replace, well, not to replace this one, but to replace the other ones we needed. The problem is I didn't realize that this nut's no good, so the inside of that nut's messed up, so I'm going to have to get a nut for it. This is 2-inch, so it's not a problem to get a nut for it, but let me see. So here's our issue. Here's our crosshead, and that's that 2 3/8 by 6 thread, and that's why we have to have a jam nut for it. So I'm going to have to come up with that to be able to put this rod in and use it like it's supposed to be used anyway. It's going to have to be a nut we're going to have to make, I'm assuming. Alright folks, so tomorrow is back on the dolly, and we'll see if we can get that thing knocked out. And not sure if we'll have it this week or not. We might have to wait on some parts. I'm trying to figure out how we're going to do this wiring. We're trying to get by, or I'm trying to get by without using the standalone harness for the 4080, but we may end up having to. The more I learn, the more I don't like it. The throttle positioner sensor for the Cummins, I don't think it's going to work on the wiring for the GM, the 4080. So anyway, we're going to figure it out. It's not a big deal. We'll, you know, we can wire it either way, and just have to buy more parts and buy more stuff, which is not what we're into, but sometimes you got to do what you got to do. And anyway, so I got a new inside harness for the transmission I got to put in. Got to do that exhaust, and quite a bit of hookup and stuff, and we'll start doing that this week, starting tomorrow. Okay, and we'll get back on the road, or the steam engines here soon after we get this truck knocked out, and we'll hopefully start getting these things set up pretty soon. I want to try to have them together and running here next, few months. So, all right, appreciate everybody watching. Till next time, bye.